with our fingers crossed. Come on, chapter 2. It's still doing it. No, it's done it. How weird's that? It's weird, isn't it? The only thing I did is I deleted this folder here. And that made it happy. Why? Who knows? But there you go. If you run into that problem with Doom not opening, maybe that's why. I don't know. Oh, and then did it just crash? No. Okay. We're on stead. We're going. We're ready. Woo, woo. Okay, so let's go back up. Let's see what we last did. Last one we did looks like contains. Yeah, that looks about right, doesn't it? So I'll give a quick recap. So what we've done is basically going through these chapters, and it's just teaching like the basics of Haskell and getting an understanding. And what I'm doing, it's actually taking a long. I'm like, this is like the 8th stream I've done of this, and we're only on chapter 2, and that's because I'm like going through it really extensively in terms of we're just playing around, trying things out, explaining like little tricks, trying to understand error messages, all things like that. So something that you might not get, from like reading the book or just following the exercises. You know, we're just I'm trying to be really like terse, I guess, with it. And then what I'll do is here somewhere I've got a YouTube channel. I just don't know what it's called. My videos. I don't think this is it. I have to go to like my channel. There we go. This one. So there, I have saved them. Oh, actually, I'll send a link to playlist, because then we can see in playlist there. Here we go. To that link, I've got a playlist called Learning Haskell using lear4Haskell. And what I'm doing is, because I think Twitch just removes your videos after X amount of time, I've noticed. I mean, I could be wrong, but I think that's what it does. Oh, clap. Thank you. That is the noise that's meant to go along with the animation, by the way, but it doesn't seem to do it. Anyway, so yeah, so I've got, if you want to go through, unfortunately, I've not really named what each one's about, other than, yeah, I just go through so much. I don't know, it's hard to tell. It might be worth following, it might not. And then I've done like slightly more complex subject like monad transformers. And I did some in the past with learning Haskell for Dummies, but I think now it's way different because we've got like Haskell language server, which you'll see I use extensively. I will show an example of that as we start. So the last thing we did, it looks like, was a poop that had a map, and I was demonstrating what map did and how you can have a list and then you +1 to it, and then that returns you a new map. I don't know what we were doing. And then concat map, but let's go down to this one, contains. So here we're trying to find, oh yeah, here we go. So you can see it's a list of list. So if we look at the type, okay, so we give it an integer, so that's our D there. And then the second type we'll give it is a list of integers. So if we look, it's like nested lists basically. You see there's a list there inside of this external list. So it's a list of lists, and then what we want to do, the answer is keep any of them, return any of the list that contain the number 3. For example, here you say we're giving it number 3, and then the hint was use LM, and then I did all sorts of crazy things, and someone in chat was like, "Oh, you could just use filter," and I was like, "Damn it!" Oh, here we go. This is not. Let me just so we have a little bit more room so we can see more of the code. So if we look at filter. Here, if you look on the very top right of the screen, up here, this is the Haskell language server, and it does this. It basically shows you the types of filter and anything that's on the documentation, which is really friggin' handy. So we can look and we can just literally straight away see that filter takes a function that does A to bool, a list of A's, and then returns a list of A's again. So for our scenario, we wanted to filter something that's true, and then every time it's true, we return it. So what we did is we did filter, and filter kind of acts like a map. You can see, look, there's obviously a list of something, and then it grabs that A out of that list and takes it and pops it in here, very much like a map, because a map would be like an FA and an FA because of any, it doesn't matter. But yeah, so the F would be the list because of functor, sorry. But maybe, I don't know if we've not redone functors yet, so let's not, you know, go too far in too early. So it's grabbing that A out, so each element is grabbing out, and it's going to do some sort of equality check. So once we're in here, we look at, so this is our function, and if you've not seen it before, this is a lambda function. Okay, so basically, actually let's do this. Oh, and we can also, there's a REPL, so there's a really good area that we can do this. Okay, so I've just got to wait for it to load. And then we can do some magic. Do I want to? No. Okay. So down the bottom, what we can do is colon. So I'm in REPL, and if you don't have it in, say, you know, if you're not Emacs or something like that, you can just load it up here. And then in that project, it'd be Cabal. Oops. REPL? Yes, like that. And then that do exactly the same. It's opening, but you know, I'm just in a different thing. So what I'll do is I'll not worry about it. We'll go back to the wrong one. Here we go. So we can do this comma space. Hello. Oh. There we go. Comma space. Comma T is like for type, actually. So it's just a shortcut of that. And then we can find out the types of anything. So I've just put not, and that shows you that it's ball to ball. So then what we can do is, we were experimenting. I was going to show what a lambda is. So let's find out, let's do this. Okay, so what do you think might be presented there? Okay, so that's, so we've literally passed it this. So a lambda is a function that's just expecting a value. And all we do in this lambda is we literally just, oh, I've just hurt my foot. I don't know how I did that. I think I just squished my foot. Anyway, it's always a bit of madness. Here we go. I've got something else. Ready? This is when I do something really stupid and it doesn't make sense. There we go. You know, don't worry. We all make mistakes, especially in Haskell. So you'll see. I'm now in my 4th year, and I'm still doing really silly mistakes. So don't worry. You know, it's not. I don't think it's hard, but it's just there's not loads of content where things are necessarily explained too easily. It's quite, you know, it's quite mathematical still, and quite orientated around academia, and you know, because it's more and more, you're seeing it more and more in production. And I've used it, you know, I've now been doing it. Well, I've been doing it for 4 years, but I did PureScript first, and now I'm doing it. I've been doing it professionally for that long. But yeah, but because of that, that means that more people have been attracted to it, and it's, you know, there's more dumb people like me that haven't got a PhD in maths and have just been banging their head against the wall for 4 years to try and understand it. So now when I'm still trying to do teaching now, whilst before I forget, you know, how potentially confusing it was. You know, I'm just trying to make that journey a little bit easier, I guess, is the key. So yeah, so what I've just demonstrated here is a lambda. So it's a function that expects something and returns, and in this scenario, we're just saying, just return it. So if you know, this is saying that is of the type P to P. Okay, and then these letters here, P and P, are totally irrelevant. They could be any letter that you want. It's just what we're concentrating is it takes in a value that could be anything, and it will return a value that could be anything. So that's what we're saying. You know, when we do, because in Haskell you can literally just, well, we've named our input A, and we're just saying return it. You know, do nothing. So if we also look at the type of ID, for example, exactly the same, except it's a different letter, but they mean exactly the same thing. So this is doing exactly the same thing. Okay, so that's all ID does. You give it something and it'll just give you exactly the same thing back. Okay, so that's how we use this trick in filter. Because filter expects, so if we look at the type again, filter expects a function that takes an a and returns a bool. So we're saying, okay, well, we can set up that function that expects a value by creating a lambda. So there's our value, a. And we know that a, look, see how, if we look at a on the top, it's a list of ints. So the a is going to be these every time. Yeah? So we're doing like a map or a filter over each of those every time. And then what we're doing is we want this to be a bool, because if we look again at filter, it needs to return, the function we give it needs to return a bool. So this function here needs to be a bool, basically. Okay, I guess another way you could write it, you could literally do it like, you know, you could have it as like another func. My function, okay, and then actually we'll leave the types out, and then I'll show you another little nifty trick. So it's going to take an a, and it's going to be lm da, except we're missing a d. Actually, let's not do it that way. It's going to make it more confusing. No, we can do it. Let's do it like that. Okay. So from there, we won't give it yet. We'll hold off a minute. So we know d. Let's do it the other way around. D and a. That's the way we're going to do it. I'm just demonstrating. And this is another good demonstration of Haskell. You can really just compose things. You can sort of abstract them out if you want, like I'm doing right now. Okay. It's not going to be happy for some reason. It will be though. Int, and it's saying any int, but it won't be. It'll be a list of ints. So we'll fix that. Oh no. No. I can't. Yes, I can't do that. I've been silly. So let me think about it quickly. I think it might be. No, I'll keep going just to demonstrate. Or should I keep going? Yeah, why not? Okay, that's totally going to work. Why haven't we passed in the a? Because the filter does it for us. Oh, I think we've explained this. It's like this becomes a partially applied function. So if we were to look at the type, well, the type of that is going to tell us a to ta to bool. Okay, so it's basically like this. Look, is it going to give us some advice? Let's have a look. No, it's not going to do it. Okay, I know exactly what the type is going to be though. So my function is going to be of the type int. Yeah, int is our first value. Then it's going to be oh, hello. Oh my goodness. A list of int, and then it's going to return us a bool. That makes sense, doesn't it? Cool, so it's happy now. Yes, there's no like. So if we look at d, for example, it should give us an int. Yep. And then if we look at a, that'll give us a list of int. Cool. Okay, and then if we now we look at lm. So we're basically using filter, and this is now we're not got a lambda anymore. We're just basically setting up a brand new function that expects a d, which is our int, which is this one. So that's like this number here. Cool. And then it's also going to receive a list of ints, which is what's coming from filter, because filter's going to grab one of these, and then it's going to do a function on it. And when it's done, it's going to do this one. When it's done, it's going to do this one. Okay, so it does all three, one at a time. And then each time we want to run this function against it. So it's like grabs a d, which we've given it, and then the a is the value that's going to be passed in after. And then when we do that, we're going to do lm on it. And then lm, it checks if an element is available. So if we look at the type, ignore all of the front bit, because yeah, you know, this is a thing with when you're starting out. Like Haskell can be a bit daunting with all these types. You're like, whoa, what the hell's that type? But anything that's after the fat arrow here, before, tends to be dealing with the compiler and the constraints. And this is kind of things where you end up worrying about that a little bit later on. But to start off with, you know, you can ignore that. So we just want to look at these letters. So there's you give it an a. So okay, so whatever a you give it. So in our case, it's saying check. Well, we don't know. What I'll do is I'll show it working, and then that'll make more sense. So lm, we'll go 3, and then we'll imagine our first list that passes in 2, 3, 4, and where was it? 5. Yeah. So it's just literally saying, so ignore this part, very bottom, it's just saying true. So does the list of 1 to 5 contain the number 3? Yes, it does. And then what filter does is that every time this returns a bool, it goes, cool, well, I'm going to keep that and pass it along. And then you'll see if we do this function again, lm3, and then it was on the list 2 and 0, it returned false. And every time it returns false, it's going to go, discard that, don't want to know about it. And then once it gets, and then it will keep that one. And then it tallies them all up together again, and it returned this. So if we then test this out, which won't work right yet, let me press start. Let me load, and then we're on chapter 2. There we go. Are they just all warnings? I think they're all just, yeah, they're just warnings. That's cool. There we go. So I've done contains, and it literally it says, okay, well, I want to check if any of these have the number 3, and then it returns us the output that we expected. So that contains the number 3, and this contains the number 3. And then we do it via a filter, which we can do like this. Filter, and then we can say, I think there's even. Okay, even's not. Oh, I've got a double. That might be a reason. Got too carried away. There we go. And that does exactly the same. So every time something comes in, it's going to be, let's have a look at even quickly. Even 2. That's true. Okay. And even 1 would be false. And it does this really similar thing with filter, just does that. It just, you give it something that expects 1 value, and it'll return you a bool. So it's from A to bool, whatever that A happens to be. In our scenario, it's an int. So we know that even, if we look at the type of even, that'll take like an int to bool. Or it might be a little bit more, it might not be so constrained to just int. It'll probably be num, which I'll display. What am I doing? Even. There, yes, integral. Okay, that's close enough. So that's a constraint, which I think we might have talked about. Hey, Chex, how's it going? Sorry, I didn't see that you said hello. And I can't see what time you said it either, because I had this problem yesterday. I didn't know what time. And then on the left here, I'll show you, look, this. And then, can I zoom in actually? You might, makes more sense. Watch this. Yeah, this little clock here. Oh, just now, cool. Well, this little thing, I thought, I didn't read, obviously, because you don't read any sort of help, you know. I don't read, things I don't do. Read manuals, instructions, and pop-ups. And I thought that was to do with, oh, show me the time. And then I just accidentally, it times out whoever's typing for 600 seconds. So some poor soul yesterday, I thought I'd missed their message, checked how long it'd taken. Yeah, and then it just bans them for 600 seconds. So I felt a bit bad. Oh, there you are, you're back. Yeah, it was you, wasn't it? I felt so bad. I was just like, shit, I've just done that, that's really harsh. Yeah. I was like, what an asshole. Yeah, right, so we've explained even, blah, 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 and we've shown how we can sort of compose these functions together. Okay, and then the next one was eta reduction. I think did we already do this? Let's have a look. What does it say? It's basically saying that if you create a function, so this involves a currying, and what it's essentially saying is, you know, we're creating functions that are partially applied. So a partial application is this. So if you look, I've partially added a b to my function, sorry, a d, which is grabbing it there, and now it's just awaiting another value, and then that value comes every time filter does an iteration, which is the a for us. Actually, it should be a's, or actually x's. Let's do x. I mean, you can name them whatever, but you tend to put an s at the end when they're like a plural, obviously. So yeah, so we're just doing, so a partial application is this, and when you do that, essentially you can have, so let's pretend foo, I don't know, foo was of the type int, and then it will return us an int, for example. So this is our int here. Okay, let me just demonstrate this quickly, and let's ignore the bar. Let's just do there we go, let's just do it like that. Yeah, cool. So we can see there, oh, should I do it like that? Yeah, we'll do it like that. Okay, so we can see there, there's an X on the first thing that goes in is an X, and it's here. But what you can actually do is this. Okay, which may look weird, but then if we look at the type of this, and this is what Recursion does. The explanation I keep giving, it's like a Hoover, just sucks it in. It's just all functions in Haskell just are waiting for, you know, it's just like Hoovers. They're all turned on waiting, which doesn't make it sound very efficient, does it? But maybe I should stop using that analogy. But I'm not going to. Right. Here we go. So I'm looking at, actually, well, I'll leave it with space so it makes it a little bit. There we go. So if we look at this type here, it expects an A and returns an A of the type class num. Okay, so in our instance, it's an integer, we'll pretend. But then watch. So if I do that, and then I do the type of plus, see how it's got an extra value? So plus is expecting 2 values. And we've basically said, well, just give it 1, and then when the next one comes along, then, you know, compute this value. Sorry, compute this function, finish it. So at that point up here, we're just saying, okay, well, we can do this little trick where we don't have to, but spot this, it shouldn't work if we do this, which I don't know why it's not come up with an error. I'm just reloading just to double check, because that should definitely, there we go, it's going to be an error. Don't know why down there it's an error, but okay. That's really odd. Normally you if you have it there declared there, it's not going to automatically go on the right. So I'm not really sure what's happened there. But it'll be happy now. I'm not sure what happened there. Oh, it'll be because of this. Let me think about it. Yeah. Why are you happy? It shouldn't be happy. It did bite me this. Maybe I've got some sort of a flag turned on. I don't think I have though. There we go. Sweet. So that's the error you're meant to see. So it's just the error is potentially not, couldn't match expected type int. So it's saying this isn't returning us int because we're not giving it another value. But that's because we've got this value just hanging around. And because we've put it on the left hand side and said, hey, I've got an X ready for you to use. And it's like, well, you're not actually using it. And this is actually returning an A to an int because it's still awaiting a value. But if you remove it, it's going to be happy because it's going to automatically curry that value onto here. And that's that in itself. What we just did is eta or eta reduction. Eta? 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 Don't know. One or the other. Yeah, so if we look at the... Does it give us an example? A perfect example is here. Add. Or we could have it as... That'd work also. Yeah, because we know that expects... Well, if we look at the type of it up the top, it expects 1, 2, and it returns us a third. Sorry, yeah, well, it just returns us an A. And those A are constraint to num. And then I'll quickly double show. I'll probably repeat myself quite a lot with these things, but it's just to, you know, in case people haven't seen it or... so if we look at the num class and how we know something, when something is constrained to a specific class, what that means is we can look at its instances. So I've just gone on Google and then I've typed in num and I've looked at the instances of num. So like, you know, like the children of num essentially. A double, float, int, and they keep going. Okay, that's anything that's related with num that we can use. So at that point, there, is constraint. So it's polymorphic is the word for it, and it's essentially awaiting the A to be constraint, or to be concrete. Sorry. And at this point, it's just saying, well, it can be any of these right now. I don't want you to, because I might use this function against any of these. I don't want to be, too constrictive right now. I just want to be ready to be open. And then so it goes int. Yeah, and that's the idea. So when we look at, where was I looking at? I forgot which function I was looking at. Add. It was add, wasn't it? This one here. There we go. Yeah. So we could add it to anything. So here, and again, it won't work if we do this. There we go. We've got an error because we've declared them on the left. This, like I said, I think it was maybe sort of 3-4 months ago. I just couldn't understand. I was doing something way more complex, and I had stuff on the left, and I couldn't understand it. I was just like, why? What? Shouldn't it? And they're like, yeah, you shouldn't leave them there, otherwise it won't work. If anything you declare and you don't use, then this just acts. It will return the actual function. But if you do have inputs up here that's saying we're expecting 2, and you don't declare them on the left, it will automatically, it'll put that one there and that one after. Yeah, so that makes sense, doesn't it? Okay, and then I guess it's saying create add. Is that what it's saying? I don't know. Maybe I think I might have just created this. Let's just do that. There you go. That works. Could be written with yet a reduction. Okay, I think it's just called. Okay, and this one's what I was explaining, partial application. So we could literally do a next int. And what that'll do is that'll just +1 whatever value you give it. And how we've done that is by first we've done yet a reduction by removing an x. And so instead of doing that, we've done that eta reduction. And then the second thing that we've done is we've partially applied a 1 to add, and then adds awaiting a second value. This is our second value. We haven't declared anything here, so it's just going to go, okay, I'm going to go into there with none of them signs, because that'll make it more confusing. So see that the initial type of the function is not changed, and it works absolutely the same. We can just skip the last argument and amend its usage in the function body. Ad hoc polymorphism and parametric polymorphism are 2 types on Wikipedia, as well as subtyping. Oh, hold on, what are you doing? In the A, I need to read. Oh my god, I've missed loads of your messages. I need to chat is paused due to scroll. Okay, sorry. Parametric polymorphism. I wonder what other kinds they are. Oh, you're looking at. Come on, look. This is like beginner stuff, Alex. Don't throw this out. Is the A polymorphic thing in num A? Yep. Well, it's sort of the A. We were doing this yesterday. Yeah, it is. Well, it's useful. Yeah. This was what. You missed yesterday's stream. I was doing type level programming with thinking with types. I think I was doing it with. Is that what I was doing? Where's there? Here we go. Yes, there. Thinking with types by see. You should have come to that one, and then we would have been able to speak about the A and what it means when you have in a constraint. But you missed out. You just weren't there, were you? Actually, you're probably asleep because I did it quite late. Well, I should have been asleep certainly because I got very confused. But that was cool. But not for today. Basically, length list a integer. What's that showing? The example for parametric. Oh, is that what it's showing? Okay. I'll try and read what you're saying, and at the same time try not to confuse people that have come for beginner Haskell. Okay. What am I looking at? Add. Form, yes. See the initial type, yes. We can skip the last argument and amend its usage in the function body. Yeah, so it's just basically saying that, but if for some reason you wanted so say you had X there and you actually want it to go in that place, it won't do it if you do it like this. It'll always patch on at the end, because this has become it's like a lambda. It's become, you know, when you leave it like that, it's literally, if you were to hard code it, it's become that. There we go. So this is what's happened when you don't have it on the left hand side here. This is technically what it does, but you can, obviously you want to make it nicer and smaller, you can do it like that. So sometimes if you see, you know, that's why it pays to sort of look at the types definition up here and what's going on, because, you know, at first you might think, well, and if we look at div, it expects an A, another A, and then it returns us an A. So obviously those values of integral, for example, which is the same as when we were doing num, there'll be a load of constructors, and then that will show you what types can fit in there. But if we imagine when we're doing like this, it is partially applying, and then we're at that point we're writing another value. Overloading is ad hoc polymorphism. Okay, I'm done. Ad hoc polymorphism. Yesterday we were doing raised, what was it called? I've forgotten now. I think they were just called raised constructors, where you can have things with tick. So you end up, you can like have a bool, and then you can have it like it's like a raised kind constructor. So then you have something like that with a tick at the front of it. Yeah, not for today. Yeah, it can in type classes. Yeah, not straight out. And then you need some. I think you need. I can't remember which ones. Look, here we go. Let's cheat. Quickly. Sorry, we're going off. It's Alex's fault. Blame Alex. You can also boo to Alex, but I want to show him anyway. What do we call it? I think it's in streaming. I think it's in here, and I think it was in chapter 2. Yes, it was in chapter 2. Yes, if you have data kinds and type families and then type operators, actually all of them, and then you can do stuff like this is the other stuff we do. Here we go. We can have a type family, and it's of not, and we've basically created a type level not. And if you're not sure, like a not in Haskell, if you do it at a normal not type level, it's literally just this. So if you go not true, it just returns you the opposite. So not true is false, and not false is true. I know you did, and I was struggling. I could have probably done with your help. It's all right. I'll do it another day as well. But that was chapter 2, so there's 2 to catch up. There we go. Look, people are dropping off now. We scared them too much. Oh well, you're gonna have to stay on now. I'm forcing you. You're gonna have to listen to the beginner stuff. I'm only kidding. It's fine. Yeah, so we were doing that. That's quite fun. But I need to. To be fair, there's some parts I was struggling, but got it. We got it. What's this example giving us here? To do. Oh, it was here. Oh, here we go. These were really simple. Well, they weren't that simple. Yeah, just do that. Leave and watch the past streams. That's fine as well. I'll accept it. So here it was saying, oh, please add types. And because we've got the Haskell language server, we can literally just do this. Add type signature. Okay. Then add type signature. So I totally cheated on those ones. I just added type signatures. Okay, so lazy evaluation. Ah, we did this. This has already been done. Sorry, I'm going over content already. Well, if you're watching this on YouTube, sorry, I've just gone over this stuff before, but we're going to do it. So we remembered that repeat, if you do it, repeat 0, it will constantly just spit out 0 until infinity. But this is to show that Haskell's lazy. So if we were to call that, which I'm not going to do, and I did do in the other stream, and it just kept going and it crashed, obviously. But what you can do is you can take, and what essentially it's saying is this is lazy, so it's not actually going to continuously spit things out until we say take 5. And then if we do, so take 2 of, repeat 0, it acts like this. Whoops. So it'll just go like that. Okay, that's what repeat 0, and it keeps going. And then if we do take 2, if we look at the result, it literally just takes 2 values. So the way to show that Haskell's lazy is we're able to have this function that's going to continuously pump out 0, but it's not going to get called until this part of it is called. So this part is like awaiting, you know, it's just there. It's the old thumb twiddler, like that. And then as soon as we say take 5, then it's going to go, okay, well, I'm going to, and, I even use an analogy. Take comes along, it squeezes repeat 5 times and gets zeros out of it. Go, like that. And you can do like ketchup, literally. So repeats there, and then like they just keep squeezing out five of them, 5 splodges of ketchup. And in this scenario, we've got take 4, glass ketchup bottle. Okay, then you got to, like, you know, give it some of that. If it's a glass one, so otherwise you're going to get shattered glass in your hands, which is not a good look. And this is ultimately a similar idea to that. Yeah, you can give me that. I don't. In case you'd have seen this in the past streams, but there we go. So if we do 1.4, it'll do 1, 2, 3, 4, and it can do another little nifty trick. 1, 4, ... I don't know. Let's go to 28. Cool, and then that'll go up in increments of 3, because 1 and 4, and then it'll go 7, and then 10, 13, 16, blah, 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 up to 28. But then if you just do ... it'll do very similar to repeat, and it'll just keep chucking them out until infinity. And in here, we're just saying, take 4 of those. So this becomes lazy, and it's waiting for something to happen. And then this is our trigger for that to happen. And then what it does, and this is something you can't do in other languages, because if you're to have something like this, say in PureScript, in JavaScript, and PureScript actually, no, had PureScript get around that, don't they? I can't remember. Can you have something like this? I'm not entirely sure if they must get around it. Obviously PureScript's not lazy, but it has some levels of laziness. Alex is going to tell me if he's still listening. Yeah, so the idea being is in JavaScript you couldn't have a function that's can... Oh, it can make thunks. Okay, so that's how it gets around it. Yeah, that's what I was thinking. I knew you could do something similar. It is a higher level type. Yeah. So the idea in lazy as, and the idea here is this. If it was in JavaScript, if you were to do that, it would just do a Stack Overflow, because JavaScript computes everything. But here, it would only compute once this is run, and then it would only take 4 of those. And then once it stops, it will stop it. It wouldn't matter. So yeah, that's pretty good. So isn't this awesome? We can now unleash the real power of Infinity Stone, apparently. So infinite list brings great power, but with great power comes great responsibility. So yeah, the other thing you've got to be mindful of is like length. That's going to get the length of a list. But if you're giving it an infinite list, then it's bad times, isn't it? It's going to keep going, and that'll obviously keep going until you get a Stack Overflow where your machine's got no more CPU, well not CPU, it'll be RAM, to try and work out how long the list is, because the list will just keep going. So you've got to be careful. And another one is we did recursion before, where we can call a function from within a function. You've got to make sure that in a recursion that you have a get out loop, where you don't want your recursion to go around infinitely. You want to get to a certain state and then say, okay, well now finish, return. Okay, and length does that, because length is a recursive function. But what it does, it looks for empty list. So it will look for a case of that, and then it will return. But obviously, if you've given it an infinite list, then it never reaches an empty list. So then it just dies, which is not good. So, task 11. Rotating a list by a single element is a process of moving the first element to the list to the end. Oh, here we go. This is why I stopped. This is where you're going to see that things aren't necessarily too much fun. So, the idea here is we want to shift things along. So, if we rotate one, this is actually just an algorithm, and I should totally know it, but never mind. And then what happens if we're shifting one, we're taking the first, sticking it to the end. And if we do 3, we take 3 and stick them to the end. Okay? And we can use cycle, it said. So let's have a look at cycle. I can't remember what cycle did. Cycle, there we go. Is it going to give us an example? It's very unlikely. Ties a finite list into a circular one, or equivalently, an infinite repetition of the original list. Okay, let's just try it out. This is the only thing that I think, yeah, and I probably said this in the last stream with Haskell. I wish sometimes things, I know you can just try it out, but it'd be nice if it just showed you a quick example. Oh, thanks, Checkser. I don't know what those mean. Oh, look. Oh, I've not changed. I wasn't expecting any of this. Oh, I've got an original animation. Okay, hold on. Because I made a new one. But I didn't expect... What do you do with bits? But thanks. I don't know what you do with them. Are they just like things? I don't know what they... I'm such a Twitch noob. Let's pretend you did this. Okay, we're going to have like a... Because this is much better, I think you'll find. I've got to show it off as much as I can because it took me bloody ages to make. Okay, so you just did that. It's a Twitch crypto or something. Ah, cool, thanks. So you can only spend it on Twitch probably. The sods. You know what they're like. But thank you very much. It's appreciated. This is what you should have got. Oh, actually, I'll do it again because it seems that the volume... Let me pause the video. The music, right? The volume doesn't come through, but if I put my headphone to the mic, it will. Get ready. There we go. I reenacted that. So that's what it's meant to sound like, but I don't know why. You just you don't get any things. Cheers, buddy. Yeah, I did another iPad animation thing. That took friggin' ages. That one. I was like, yeah, that's easy. No time. And it's little dudes going. Brrr. And I've totally forgotten what we're doing. Cycle. Back to life. So cycle said it took. Do I take commissions? What, to do little animations? Nah, I'll do you an animation. Let me know what you want. iPad animations. Yeah, I use... Well, it's actually my wife's iPad. I use... Is she here? Becky! Yeah. What's the program that I use? Procreate? Yeah. Yes. Procreate. That's what it's called. Yeah, and I just use that. And then you can have it where, much like Photoshop, you just get a bunch of layers, but then each layer's a layer of the animation, and then you can group them. So then you like that one, each layer or each cell of the animation's got like, I don't know, I think it's got like 4 layers each or something, and then I just do them all. And that one was so long, such a bad. Yeah. Oh God. So if you want something that good, then I don't know. Yeah, maybe you'll have to be really nice to me. Cycle. Okay, let's try it. So we've got it here. Do you know what cycle does? I haven't got a clue. Let's have a look. 1, 2, 3, 4. Oh shit. Okay. No. Oh, okay. Okay, so cycle clearly just keeps going round, doesn't it? So we probably want to cycle, take the length plus 1, and then drop 1. It'd be something like that, won't it? So take, hold on, yeah, so if we rotate it by 1, it'd be the length. Oh, but we can't, yeah, we can get the length of the original, can't we? So that's the length. So let's pretend we've got the length plus 1, which is 6. And then we'd cycle 1, 2, 3, 4. 1, 2, 3, 4. Which should then, especially when you spell it wrong, we spell it doing cycle. There. So that does 1, 2, 3, 4, 1, 2. Okay, so we don't want 6. Was I trying to do 5? Yeah, that's fine. 5 is 6. Okay, so we're pretending we're doing sugar. That's not going to work, is it? Do you think that's what it is? Maybe. Yeah, that's what I was thinking. So, well, for this example, I think that's right. Well, I think it's like 1, but it's going to be more. It's going to be length plus this plus 1. Yes, because we have to get. Yeah, that's totally what it is. So let's find out. So I think that we take a value which is an integer, and then the second is of x's, okay, and then we want to do a which way are we doing it? Yeah, so we're going to do take. Oh, there's going to be multiple things here. I don't want to use do blocks yet, so we'll do where. I've shown wheres already, so that's fine. We'll call it sci. Cycle. So you're saying take 4, so drop cycle x's. What do you think that? Okay, let's try it. Okay, I see where you're going. You're going totally different cyclops. That's what I feel like sometimes. Let's try this. What you were saying there. So drop. So let's imagine we're doing the first one. So we're dropping by 1. And then, yeah, Cyclops is better than Sci. I'll give you that, definitely. I'm not, I was copying what you're doing. So drop 1, and then we're doing cycle x's. Let's have a look what that results. So we'll do reload, and we'll do rotate. Actually, we can literally just copy that. Just to get an idea, see what that returns, and then I'll explain it. Yeah, okay, well, that's not working. That part, anyway. Don't do that. Okay, so that's cool, that part's okay, but then we were saying take 4. Okay, so let's just imagine that's I think it might be the wrong way around. It can't ever drop 1 because it can't get to the end. So don't listen to. You need to pump the ketchup. Yeah, I know. The ketchup bottle's not having it here. We need to take something first. So I think here we need to do a take first, and then we need to take. Here we need to do some calculations because we need it to take the length of x's. Yeah. Length of x's plus the I. Plus 1? No, let's just do that, okay? Let's save that. What's not happy? First and foremost, there isn't an x, there's just an x's, okay? Reload, and then, what was it called? Rotate. Was it 1, 1, 2, 3, 4? Yeah. What does that give us? That's cool. Okay, so we've got what we want here, haven't we? If you check it out. Yeah, I think you had it right, just the wrong way around. And then we drop. So we do a take, which we want it to take a cycle of x's. So that will just keep repeating itself round. And we want it to move by 1. So we have to get the length, because the only way to take, we need to know the length of this, which is the length of the x's we give in, and then plus 1 to it, or sorry, plus however many we want to move it by. And then we need to be able to drop that exact value from the front of it. And then I'll explain it again. I think that's going to be right. What do you reckon? I reckon that's going to be enough what do you call it? It's going to be enough. Ketchup squeezing. 2, 3, 4. Okay, now let's try another one. Rotate 3. I don't know. Let's see how we feel here. I might rotate 3, 4, 1, 2, 3. Yeah, it did it. Okay. So, can we split this up to be a little bit nicer? Because I guess when you look at it, it's quite a long business, isn't it, going on here? Let's do that. So, I don't know. It's not too bad. Yeah, we can do. So we can do this. Oh, fireworks. Bloody hell. Len. Let's do that. Oh, no. Let's do... let's call it new len. Yeah. And that's going to equal length of x's plus 1. No. Plus I. Cool. And then... No, it's outside, dude. I don't know who it is. We're mainly being locked down here in the UK. That is just not working at all. People are just giving single fucks and are just doing what they want. Which is alright, fair enough. Okay. Yeah, so that's that. I guess that's not too bad. That's like a little bit more readable, maybe. Yeah, okay. So we know how take works. It literally takes a number and whatever length of, whatever list you give it, it'll take that number of the list. So when we do it here, so let's have a look. So we do take 2 of 1, 2, 3, 4. Oh, there's no music. Why have you stopped? We've heard that one. There we go, but go back to the beginning. I've been making more songs. I think we're now on like 2 hours worth. Which isn't bad, isn't it? It's getting there. It's a lot of MIDI that I've been converting. Like this. This is just some random MIDI I made. Here we go. So take 2. We notice it does 1 and then 2. Okay, so it's taken those 2. Fine. So we know that when we do take the length of x's, so it's going to get the length of this, which is 1, 2, 3, 4, plus what you call it, plus the number that we give it. So that would be 5. So we know that when we do cycle, if we take 5, well, if we take 4, it'd return that. And if we do 5, cycle just keeps spinning things around. Okay. And then it wouldn't go to 5 though. Yeah, so cycles just is an endless list of this that just keeps repeating itself. Hello. Don't know how that turned into that. There's an endless list of that. And then what we're saying is we're adding rotate negative still works. Rotate negative. Don't know what that means. Is there like a function that you can rotate and there's a function called negative? Maybe. I don't really know them. Rotate -5. I don't know what rotate is. Let's have a look. Let's go to Google. Oh, yeah, I'm with you. No, surely, no, because minus. Why would you want to rotate the other way? We're only rotating. Yeah, I did, but don't start making things harder than they need to be, Alex. Okay? We're not going to rotate things the other way, but we're going to give it a go. Why not? I don't know what's going to happen here. What do you reckon? Yeah, nothing. No, hold on. That might still work. It's just that I need to do this. Ah. Ha! That didn't work. It's just returned as 1. It's returned as something though. Yeah, it can't do it. No, we can only rotate. This is is that clockwise or anti-clockwise? Well, it doesn't really matter because we don't know which way the numbers are flipping. It can only cycle one way, okay? We can't go the other way. So, yeah, positive only. No negativity in this stream. Not having any of that. So, I see what you mean now. I thought you were going on about like another function. You could do it in another way. Okay, so now we should be ready to do a final boss. Oh my goodness, it's a final boss. Let me have my fun. Yep, we're not going any other way. Fun's over. No, fun's happening. Ready for the final boss at the end of this chapter. To defeat the boss, implement the reversing function. It takes... No. Oh, hold on. Oh, it just reverses the list. Okay, that's not too bad, is it? And it's called rewind. Yeah, that's easier than what you were asking us to do. I didn't want to do that one. So this one takes a list. But lucky you it's not. Thank goodness it's not. Yeah. This one's not too bad actually. You can just like, oh, definitely don't do that one. So we can I think we can, well, I think I've shown this already, but and then hold on. Yeah. No, is this gonna work? Yeah, it will work. Oh, this is very, very inefficient. No, of course it's not gonna work. I'm going to infinity. Look at me trying to be a smart ass. No, but it will work. It will bloody work. Watch this. Especially if you do it like that. But I've got to sort out my not being able to handle that. Okay, so rewind. I'm really getting annoyed with that. I keep pressing. I'll show again. It's the fault of... I can't really see. These buttons here, they're all a bit too close to down arrows and my square brackets. And then if you go on any other computers, square brackets are at the top, like next to O and P, but down here they're like at the very bottom of my tippy fingers, and I keep getting them wrong. What was I doing? Rewind, yes. So it literally just takes A, whoops, and returns a list of A. Not A's, A. Oh. Come on. Okay, now we're happy. But we're not happy. Oh. No. Don't do it like that. It's not going to work, Vince. We're going to have to do it properly, aren't we? No. You did it now. Summon. No, we won't summon her. She's far too busy to do that. Okay, so we want to... How did I do it the other day? So we want to append X to the end. I did this by accident the other day. I've got to try and remember. Okay, well, I mean... Whew, it's happening today. Okay, so we've got... Well, we've got X is of type A and X is of list of A. Okay, and we want to do an infinite loop. I thought that would have worked. Why didn't it work? Or is it just hold on. I guess this... Okay, let's try this one out. This should return... Please stop doing that. Come on. Did it again. That one. And then let's do rewind X's. Okay, so what's this going to do? Sure, it's just going to return an empty list. I mean, that's the expected output. If it's not, something's happening. Okay, so we've got that good. Now, I mean, the other way is we're going to have to keep some sort of state. Because you'd think that you could just keep cons in, but I guess it's not going to work like that. I thought you could literally just do this, but then it's saying it can't do the infinite type. I really thought you could do it like that. I really did. Is that because when it gets to there, yes. So the problem being is to do a list, it has to be like this, which that will work, but check out the output of this. Actually, it's going to be exactly the same. What's wrong with you? Rewind's not available. Why not available? Okay, there's an error. That's probably why. Yes, okay, there's an error. I just made something up, basically. Saying, Vince, stop making stuff up. Ah, Alex, where you gone? Come back with some help. This is meant to be beginner friendly. But it's not. It's not being friendly to me. Okay, so basically you can't do this. I'm trying, because you can do the other way, where... Or is it just the other way? No, because we're just putting things literally back in the same place. Because check this one out. This is going to be fun. Oh look, we just returned exactly the same thing. Actually, should we just... Okay, I'm going to be really naughty. Let's just look at reverse. Don't do this. What am I doing? Reverse. Never do this. Just work it out yourself. Don't be lazy like me. Oh, you do it within there. What? Hold on. Reverse 1. Oh, L. Okay, well, don't do that one because that's kind of what I was thinking of. Colon X. Look at this. This is interesting. Ah, that's the magic trick right there. Except there it is. This is what we did by accident the other day. Okay. And I can even... Except it's called rewind. I can explain this as well. And we can keep the type. Yeah. So I can explain what's going on here. Cool. So the problem we were having before is when we construct a list. So say, well, when we cons a list, so 3, 2, 1, that won't work. Okay. So the only way you can do it is you have to cons it into something, and that something has to be that. You've got to put it into, because if you remember with Haskell, anytime we do something, we're creating a new, we're not manipulating the original, what do you call it? We're not manipulating the original list. We're always returning a new list. So there, see, that would work because we're putting it into an empty list. But if we just do that, which is what we were doing before, it's just going to fail because it never puts it into an empty list at the end. And it's that way around. You can't do it this way around either. You can't go to... Whoops. I don't know, whatever. That doesn't work either. Okay, so you can't... So that's what we were doing. We were going, oh, put it at the beginning. No, we can't do that. So what you can do is we do a recursion, but it's from within. And then what we're saying is we're going to pass this list of A's, but we're also going to pass a value of an empty array as a start value to rev. Okay, and then if you look at the types, it literally watches if the L, which is our list, ever gets to empty list. And that's how we get around recursion. So it'll look if that ever gets to empty list, and then if it does, just return the A. Okay, so let's have a look how it breaks it down. So the first time, let's imagine let's just go through a really simple one. We do 1 and 2. Okay, so this will be 1 and 2, and that will be 1 and 2. So that'll be 1, and that'll be list of 2, and then that will be empty list. Okay, so what we're doing at this point is we can do this. We know that we've got the number 1, and we've got an empty list as our first value. Okay, and yeah, for some reason it'll take ages, but it'll return us a list with a value of 1 inside of it. Okay, and at that point we can take the rest of the list, so we can call rev again, so we'll be calling rev on our second value, and then we'll be passing along our new list, which is got x and 1, so as we showed, it'd be that. Okay, so then we call that again, and then at that point we can only get x out, which would be a number 2, and then we can only do 2. I'm just going to split that up. There we go. So we can only pass on, this would be 2. We can only do that. So if we look at that, yeah, fine. That would be 2, 1. And then this, just the x's from there is actually just that at that point. And then we'll hit this one then, because if it'll look at the first value, which is the x's, which is an empty list, and it'll go, oh, it's empty. And then it'll look at what the second value was, which was 2 and 1. And it'll return that, and then it'll be backwards. So you see how we're creating a new list here on the right hand side, and then we're passing along the old list on the left hand side. And the magic bit is the fact that we start with an empty list, and then we can do it. But you can't, like I was trying to do that recursion this little bit from within without having to pass, because I did say like, oh, we'll probably need to keep some sort of state to pass around so we know. And that state is literally, this is the new, that's the old. Every iteration, take the front of it, add it to the end, and then just keep doing that. Sorry, add it to the front and keep doing it. So if we get the very first one, go to the front. So, imagine we've got like a list of 5. Every iteration, it'd go, which way around would it go? So it'd be the opposite way around. Yeah. So on the first iteration, it'd be like it'd be 1, and then on the second one, the 1 would be inside, and then it'd be 2, and then after that, because this puts it to the front, doesn't it? 3. Does that make sense? 4. And then 5. And then this, that value at that point, because we've gone through all 5, there's nothing to add on anymore because we're passing back this. And then it'd be like, oh, okay, well, just return my new list, which happens to be backwards. Rewind, or really reverse. And if you're like me, you cheated to get to that point, but don't worry about it. It's fine. As long as you understand how it works. That's what's important. Cool. Okay. Well, clap to ourselves. We got through chapter 2 with no major hiccups, I guess. We can go on to chapter 3. Why not? Let's do it. I wish my laptop wouldn't be so frigging noisy. But I'll show you what I have. First and foremost, let's go to this. Go to that. About this Mac. Ready? This isn't like a... oh, I can't really show it because it's got like my serial number. But, oh, I can do this though. Get ready. Get ready. There's another way around it. Without showing stuff. Here we go. Take the picture. Rewind, reverse, refer, review. Done. There we go. This is my Mac. So I've got a 15-inch 2019, 2.4 gigahertz, 8-core i9, okay, with 32 gig of RAM. And I've also got, which I can't show you, but I've got like a the top of the range one, the Pro Vega, 4 gig for my video. Yeah, and you'd think so, wouldn't you? Still, the fans are going mental. I can't direct you there. But if I turn this off, look, this is also another reason why I've got a bit of audio in the background. Ready? I'm pretty sure you can hear that. Yeah. Yeah. Thanks. 3.5 friggin' bleh, bleh. And also, that's not the only... Oh, yes, go on, let's have an Apple rant, fuckers. This will get people going, leaving the stream. And the other thing is my solid state drive goes when it does heavy reads and writes. Had it replaced. They literally changed a whole motherboard because they're all attached now. You can't just remove things. You have to replace a whole motherboard. Kept the old, and you know, I was having issues with coil wine on a solid state. Like, what the fuck? I mean, it's not even got any like things like that in it, but I don't know. They replaced it all like the whole motherboard, but they kept PSU. Do you reckon? Maybe it's that then. Honestly, it just, once you hear it, can't unhear it, can you? So it did that, and then my MIDI, not MIDI, my up here, what do you call it? Oh my god, I'm having my Bluetooth and Wi-Fi card. That they're obviously both on the same thing. They thought, well, since we're replacing the whole machine, we won't replace the Bluetooth and Wi-Fi thing, which I told them wasn't working. That doesn't work either. So that just, you know, sometimes I have streams that work, sometimes I don't. Yeah, and I've been arguing with Apple for a long time. And obviously, as you can tell, I fucking bastards. Excuse my language. And I can't be bothered. And then the only way to complain with Apple is literally, and you can only complain via post. You can't complain via an email. Technology for you. Yeah, so you know why they're doing that, don't you? Because how many people are going to want to write a letter? And I keep meaning to do it because technically, Twitter them to death. Yeah, that ain't gonna do shit either. Because all they do is they refer you. I spoke to like these top level geniuses. I'm in frigging quotes. These quotes, you see these quotes right there. Yeah, not just at the place. Because they're geniuses there too, but on the phone you get another bunch of geniuses, and apparently there's no one higher than them. When I was trying to raise it, they're like, no, we're at the top. Like, what? So, what do you mean you're at the top? No, you're not. Why are you lying to me? No, we are. What the hell? Like, yeah. And this just kept going on, and it's been going on for about a year now. And the noise started within 3 months, and I've tried to return, and they're just saying that. Nah, well, this is the only problem. Look, is all my down here, Logic Pro X, and my editing software, and all that stuff. I can only get on Mac. So maybe I'll get off Mac for, I don't know. Yeah, maybe I'll get off it for like developing. I'd be tempted, but otherwise no, for other programs. And I do like the operating system. It's not too bad, but it's going to be. I'm not ready for the pain, the hell, when they move over to a different what are they moving over to a new chip, aren't they? They're going with ARM or whatever it is, so you're guaranteed that everything will be broken. But I've done Mac at least 20, yeah, I mean, okay, at least 16 years I've been on Macs, maybe 20. And you know, so when I did, like, I used to do development really early when I used to do like WordPress sites and stuff. They'd literally just like no programs for Macs. Like, it was just, hey, cool, man. Well, take that. And thanks for the bits. What they were called? The Twitch bits. Yeah, say hi to the dog. Like that. But yeah, take care. See you later, Alex. Yeah, well, since Alex is gone, I'll stop my rant on Macs. Stuff them. I need to get a new one. Oh, no, sorry. I need them to give me a new one. Mothers. Welcome to chapter 3 of our journey. Courageous Knight. Yes, we're a knight now. Glad to see you back for some more challenges. You fight great for the glory of the functional programming in the previous chapters. We are grateful that you are continuing to walk this road with us. Hey, gotta give credit to this repo because English isn't their mother tongue. Bloody impressive, isn't it? It's pretty well written, I've got to say. There you go. I do link it everywhere, but I'm going to link it some more because they deserve the credit. Really hard work. I think they're not doing... I mean, it does all show on here. It does show you. Hey, Gil Christian, let's go. Oh, I like that one. Didn't know that existed. Nice. Yeah. Just have a look. Read it. Try it. But you can't at them anymore because, seriously, they must have got so busy. I think they said... There's somewhere... Hold on, let's have a look. Let's go on Twitter. At... what? There's a report somewhere. Vrom? Is it Vrom? Yes, Veronica. Is it on that one? This is one of the contributors. And then there was... No, where was it? Where was it? There's like a report of the amount of people that did this. Where was it? No. No. Come on. Oh, that's me. No. There we go. Look at that. So 187 people took part. Let's click into it. Zoom in because you probably can't read it. So 31 days it was run for. 187 people. 481 PRs they got. And they replied to each and every single one. Bloody what? You know, we need to get them a medal. We need to get them some Twitch bits, whatever they were. Thanks, Alex. Yeah, because that's incredible, isn't it? That's a lot of reviewing. I think they were, I don't know, let's just go check it out. Let's see if they're forks. They got forks. I don't want to see my fork, though. No. Oh, can't you see forks anymore? I thought you could, I thought there was a way before. You could click forks before and see it. Branch. Is there an insight maybe? No. Contributors. No, that'd be just themselves. You'd think. And then also they got a load of maybe on network. I can't remember what it was called. Where it shows you. Is that gonna? That might show us all the forks. But anyway, they of all of those. So we're looking at 481 PRs, and they replied to all of them. Bloody hell. Yeah, so that's a good effort. And then there's also, oh actually, if you want to read it, there's quite a lot of stats of, yeah, look at this. There's loads of stats of people. I think people, they said that people got to chapter 2 and then they kind of dropped off between 2 and 3. Like not as many people finished 3, which is what we're on. We're not going to, oh look, you can see all the people. Look at this. Oh no, you can't. That's not it at all. Okay. But yeah, so they said that there's a big drop off between those two. So they need to maybe like not make it so difficult. But I don't know. I mean, if you sort of draw, if you do like a linear regression line, I don't think that'd be too far off. I think that once people got to 3, they didn't find 4 too bad. Let's find out. Stop talking. Do some coding. Okay, so going to continue our road. This chapter requires the knowledge from the previous modules. Yep. So it is highly encouraged to at least look through the material of those chapters. Well, we've not just looked, we've done it. So look, let's refresh how the training works. Okay, so you are here, chapter 3. At this steps, you are going to learn. Maybe this was it then. Maybe it's like, I don't know. Maybe this sentence put people off. I don't know why it would. You know, it's like, let's refresh. Maybe they don't. Okay. I don't know what I'm talking about. Ignore me. Don't listen to me. The only person speaking. So at this step, we are going to learn more about types in Haskell and explore type classes. This is actually, this might be why people got a bit scared. Because really, I don't think we've not really spoken about other things. Has it gone on? Did it do? I don't think it did. It's not really done like. Let's have a look. No, this is like. So functors come in chapter 4. It looks like. Yeah. So I don't know. What do you think? Do you think it's? I don't think it's type classes before functors. Maybe. Maybe they don't seem. Types in that is understandable. Algebraic data types. Maybe people saw these words and were just like, I'm out of here. Which makes sense because, you know, if you're starting off, the other stuff wouldn't have been too bad. Some of the exercises even I struggled with. Not like megally struggled, but, you know, they would have taken time for sure. And then maybe you come to this point and you're like, what are these words? And they do get explained, I'm sure. And these words aren't as complex as what. Yeah, I guess it's just, you know, that's the thing. That's the thing that's good and bad about Haskell. Good because that's terse, isn't it? You're not gonna mistake algebraic data types of anything else, are you? There's not. When someone says algebraic data types, you know what they're talking about if you know what it is. So that's good, but bad. It's called algebraic data types. Do you know what I mean? And parametric polymorphism. You know, it's like, what? What are you on about? But it just takes time. It'll come. Maybe this is the stuff that might need to... Which is why I'm doing this stream. Because I think, you know, I can simplify and I can sort of, you know, take away this scariness of the words. Because I, in all honesty, I always end up forgetting what they're called. But if someone says, oh, how do you do this? I'll go, oh, yeah, you do it like this. And I'm like, oh, well, that's actually blah, 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 blah. And I'm like, oh, is it? Cool, yeah, nice one. So as usual, the explanations are in the Haskell comments of this module. We are leaving the numbers of tasks on our path. Let me just, actually, I haven't checked. It feels like it's not quite zoomed in enough for some reason. I think it's not. I'll just pump it up a little bit. Excuse me. It's not COVID. Well, I hope anyway. I'm not seeing anyone, so I don't see anyone anyway. Just my poor wife. Where's she gone? She's gone downstairs. Oh, what's the time? Yeah, I'm probably not going to hover too much. I don't know how much time I've done already. It's not really showing. I've done something amount of time. Okay, so as usual, explanations, blah, blah, blah. After finishing PR, you can choose to summon us. Really nice. Don't summon them anymore. Well, you can do. Maybe they'll still reply. But I wouldn't if I was them. Look at your solutions order to give us some advice on the code. Blah, 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 blah. Okay, ready, set, go. Are they monoids, are they? Hi, by the way. Monoid. No. Are they? I can't see them. Mod, no, or the. No, maybe in another. Let's have a look. It's, oh, there's no monoids anywhere. No match found. But there's functor. That's a bit weird, isn't it? Okay. Is that what it is? Yeah, there it is. Oh, okay. Oh, yeah, class append. Nice. Good spot. Which is semi-group. Yeah, it is. See, this is all... Yeah, God. I mean, I don't... You know, this is what, like, is great and bad, isn't it? It's like, it's great because you can't mistake it for anything else. It's bad because how that can be... You know, we just had, like, a simple... Well, what... It's not, obviously it's not simple, but we've had a conversation, you know, you're saying, oh, they've got monoids, oh, there's semi-groups at least, and then, you know, if you're starting off, you're like, what are they frigging on about? You know, but, yeah, it's basically, we'll see. It'll be easier once you see. I always find looking at code, and actually, you know, someone demonstrating a code is way easier, and then things are more likely to sink in. And also, you know, if the teacher's dead exciting... and enthusiastic like some, then it's easier to learn. I'd hope so anyway. Absolutely. Thanks. Yes, I'll take. I've given myself the praising myself. Yes. I like it. Thank you. Hold on a second. Just patting myself on the back. To be honest, it's these times are pretty boring, and then like I don't mind doing this because I'm just iterating what I already know, and I think I make it fun by then doing the more complex stuff like I did the other night, because then I'm learning then, and it kind of like pushes you, you know. It's like, oh, I could sit there and just sort of go over YouTube and not really do much because I can't be asked, or I could just do some streaming and hope that people learn from it, which is like a bit more. And if you do streaming and it like entices you to do, it's like, yeah, go on in, I'll try a little bit more. But if you tell yourself, I'm going to do some OSS, and you're like, yeah, or I could watch this YouTube video that's totally wasting my life. Yeah, I'm not really, computer games aren't going in this household, so luckily I don't do that. Well, luckily for me, yeah, because I'll probably be quite addicted to them. Right, some Haskell features are not enabled by default. They're enabled by corresponding extensions. So language features. So using the pragma language at the top of the file, which is here. Okay. So when you use this, there's lots of stuff on when you have a Haskell file, or let's go into a file because this is file specific. What I'll also show is I'm pretty sure I've slightly spoken about them, but let's go over some other ones. Here we no, they're GHC options. Where are they? Oh my goodness, where are they? Wow, that's lots. Here, no, it's GHC options. They're at the top then, somewhere. Wall isn't one of them. What? Are they here? No, GHC. I thought maybe there are GHC options. They are, aren't they? Yes. So these. That's just saying I want this to be project wide. These, and then if we look at that, I want that to be file wide. So it's just within a file. This file can use instance signatures. Okay. Which is going to be explained what it is. So we've enabled instance sigs. Oh, what else did it say? The fact that they are not enabled by default doesn't mean they are experimental. Yeah, so there's a thing that what's happening is potentially a lot of the ones that people put in their Cabal file by default are going to become defaults. So they're going to be there, whatever. It's some of the special ones. When you do potentially more advanced stuff, then you start creating some certain ones. And what it means is it just allows you to, it allows the compiler to know that you can use specific types of code. Like one of them, which won't work here, but when you do type level programming, you can do things like, no, hold on. Let's do it like that. You get, oh my good, whoa, my keyboard's, can you see that? I'm pressing, whoa, come on. Don't mess with me. Yes, you can do things like that with a tick, which is of type level programming, but you can't do it off, you have to have a specific language extension turned on to be able to do that. If it's not turned on, you can't do it, and then you get a compile error. Yeah, hold on, have I got, no, I haven't got many things open. I don't know why it's gone a bit slow. Oh well. So in this module we enabled instant sigs, feature that allows writing type signatures in places where you can't by default. Okay. We believe it's helpful to provide more top level type signatures, especially when learning Haskell. Okay. So imagine that that's the top of the file, because this is all commented out. Hold on. Yes, because all this stuff here is all commented out, that's technically not the top of the file. As long as this, oh hello, as long as that is above where you declare the module, okay, they'll work. You can also put them underneath in with some things, but that's the where you tend to put them, at the top, right at the top of the file, and then you declare your module where, and then you do your imports. Okay, so we believe it's helpful when learning Haskell. Okay, types in Haskell. Let's talk about types. In the previous chapters, we have already worked on a lot with them, and we bet you can name a few at this point. Yep, but we mostly were operating on primitive types like int, bool, and we saw the function boom a lot, which is, I think they're talking about the arrow. So, you know, so when you do like that, okay, they're talking about that one. Okay, we briefly touched tuples. So this was a tuple. Okay, that's a tuple. But we learned that lists are far more complicated. And then a list was literally a list of whatever values we want inside. Oh my, there's like a hang. It's doing a weird hang. I might have to close this file, but we'll see. And that's a list. But we sort of manipulated the list, didn't we, and did bits and pieces with it. So Haskell has several different ways to create entirely new data types. Let's talk about them. So data types. We've kind of created quite a lot of data types, I think. You know, it's like, it's a keyword data. Oh, let's just read it. Okay, I might shut this file. Because look at this. I'm like clicking around and whoa, see that? That was magic. It just disappeared. I mean, terminating. Hold on a second. I've deleted loads of stuff. Here we go. You gonna be happy now? I don't know. Let's get rid of that file. Let's get rid of that file. Let's open stuff up. Let's go to chapter 3. Let it load up. Yeah, I'm not sure what's going on. What's the CPU saying? 20%. That's not bad. I mean, it's still whooshing like hell, but it's not too bad, is it? Okay, I don't know then. Okay, let's do another one. Let's kill that session. Maybe that'll do something. And then let's... Okay, so I'm going to do like this until we need it. Hopefully that will help it out a little bit. Oh, something must be going on because my CPU's like... It was on 20, now it's gone down to 12. So, something was happening. That's why my Emacs was slowing down. So, let's... First bit. Type aliases. So, the simplest way to introduce a new type in Haskell is type alias. Type alias does nothing more than just other names to already existing types. Okay, so we can think of it. You know what? I'm going to grab that and then pop it in here. Oh, more fireworks. Okay. So a type alias is basically we're just renaming a known type. This is really useful. Scenarios. So you can have type name, which is a string. Yeah. And that what that essentially means is I don't know what's happening here. Sorry, I'm just looking at my. It seems to be flowing. Maybe my internet's going a bit weird, so it might be crapping out. But we'll do it. And then what this gives us the power of is when we want to... So instead of having, you know, with it like this, instead of having a function that goes... it's still hanging a little bit. Yeah, something's up. But I'll keep going. Yeah, so instead of having a function that goes string to string... You know, that's if you come back and you're just going to see a bunch of these functions that are all string to string, you're going to go, oh, okay, well, thanks. Yeah, okay, that's a string. Cool. A string of what? But you can give it an alias. Yeah, and then it can be a name. But fundamentally, it's still a string. Yeah, so that's pretty useful, isn't it? And you can do the same. Look, you can literally do it with a pair, so like a tuple pair. A list of ints. Okay, so that makes sense, doesn't it? Type aliases are just syntactical sugar and would be replaced by the real type during compilation. So they don't bring too much to the table of data types. However, they make the life of developer easier in some places. One of the most common type aliases is string. Hey, exactly what I'm talking about. That we already mentioned in the list section of the previous chapter, and it is defined in the following way. So type string, there we go. That literally just demonstrates, well, it's not what I was talking about, but it's the same. It's an alias. So a string is literally a list of chars. So we know that that when, you know, the way, oh, I'm not going to do it, but G, H, etc. Okay, so look, that is equal to that in effect, and then to demonstrate that is here. So a string is literally a list of chars. Okay, actually I've done that wrong. Those should be single ticks. Sorry. I don't know why I'm doing them all, but why not? Okay, so that's what that's saying. Okay, so now, what time is it? Oh, it's okay. I'll probably do another 15 minutes and I'll give it a quit. Now it makes much more sense of why string is related to lists. Yeah, so that makes sense, doesn't it? If you think before we were able to map over strings and do various list things with strings, and that's because literally they are a list of chars, or chars when it's a plural. You can see that any list functions could be used on strings as well. Yep, due to implementation detail of lists, such representation of string is highly inefficient. Okay, it is unfortunate that the list of characters is the default string type. Oh, okay. Experienced Haskellers use more efficient string types like text or byte string. So yeah, so when you use like text and byte string, you're carrying around the full, it's not a list then, it's just like a block. It's just a block of text. So you then can't do the same sort of stuff that you can with string. Byte string, yeah, that's when you're not just dealing, well, it's just dealing with byte strings basically. So things like bytes. Text and byte string correspondingly. So it's just saying that from Haskell libraries, text and byte string. I've been doing stuff on the where is it? Where am I doing? I should show. I don't know what I'm doing here. I was going to show. I was maybe going to. I did show this the other day, but I might do this in the stream also. Oh, excuse me. I should put my hand in front of my mouth and not speak when I yawn. But I just did all of the above. Here. So I added this stuff to the byte string. And we just need to run, well, we need to fix this, and then we need to run some benchmark tests. So I might do that next time. But yeah, this is byte strings. Kind of unrelated, wasn't it? I just wanted to show off. Literally, I mean, look, it's definitely not showing off. All this was to do is you have an unsafe head and unsafe tail, but you can get those values if you use an uncons or an unsnock. And that's basically what I did. Wherever those were used, I replaced them. In essence, well, I had to work it out. And then I had to look at the code to see if, what was I seeing? I had to look at the code to see if the core code that it generates was the same or not. And it was the same, so it's fine. I could change it. Because obviously you can think a lot of people are going to be using that byte string library. So yeah, you have to make sure. Anyway, another common type alias is a standard library is file path, which is the same as string, which is the same as jar, list of jar. So type file path is string, which is then an alias of that. So usually you are encouraged to introduce new data types instead of using aliases for existing types. But it's still good to know about type aliases. They have few user cases, and you can meet them in various Haskell libraries as well. Okay, so ADT, so this is algebraic data types. Let's go into them. Let's not limit ourselves with just type aliases and define some real new data structures. Okay, are we the creators of a new world or what? Pretty much, yeah, I think so. Why not? I'm a creator of a new world. Type in Haskell is like a box of information description that the object of that type should contain. So I think it's saying that types is basically, yeah, it's a description of what can be part of that type. So example, here we go. I'll give you an example here of books, but we'll keep reading and then I can give more examples too. To give you some basic understanding of the difference between these two, let's go. Oh my god, I got a dry throat. I've been talking for too long. I don't know how people do, like, I think Vlad was saying he was going to do like an 8-hour stream or something. Oh, I hope he's drinking lots. What is he going to do when he comes to eating? Stream, I'll have to watch some sort of video. Stream becomes a little bit boring then, doesn't it? I'm just gonna eat. Yeah, I think he's doing it. I think he's doing it to help the Haskell Foundation. I think that's what he said he was doing it for. I don't know. Good on him. I watched a bit of it, but not the 8 hours. That's heavy going. To give you the basic understanding, a book. Okay, hold on. Start again. To give you some basic understanding of difference between these two, which is the type alias and an ADT, algebraic data type. Let's go to the bookshop. A book is there represented a product type. Okay, so we'd have like a product. Each book has the name, author, cover, pages, etc. Okay, so this is when you use types. You want, if we pretend we've got an application that's to do with a bookstore, and each of those be named a product, and we want to know so we'd have, because obviously bookstores don't just sell books, they'll sell other stuff, so we can have like a type of product, and then we can have like a type of a book that's part of the product, and then a book can have specific here. So if you look, it's got a name, an author, a cover, and the pages. Yes, whatever it might be. Okay. Yes, and all of these properties are mandatory. Okay, and come with the book. Bookshelves, in its turn, is a sum type. Each book in a shelf is a different type. Okay, so a bookshelf. Where is it? There. Where's a bookshelf? Okay, and then that's just saying a bookshelf would be a bunch of books. Okay. So if we look at that kind of, okay, yeah. Don't worry about what sum types means right now. It will be explained. Each book in a shelf is a different type, and you can choose one of them at once. There is no such book where two or more physical books are sewn together. We will show you examples now just to illustrate all of the above, and then we will explain each concept separately. Yeah, that's what I thought was going to happen, because there's a bit of information that might not make, like sum type. I mean, algebraic data types already. It's all a bit what? So we've kind of given an example, a product type and a sum type. Okay, well it'd probably be nicer to demonstrate what they look like, which is what's going to happen. So, oh look, there's like a little boop boop boop, and we use and in the product type. So it's and. So a product type is this and that and that and that, and then a sum type is that or this or that. Okay, so it can be either one or the other. So I can actually, does it give you an example before? No, go on. Let's read on, because I can show you what the sum and a product type would be. But we'll see if they do first. Okay. So we use or to tell only about, yes, we kind of, and is a logic correspondent, blah, 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 blah. Yeah, don't worry about that bit. And or corresponds to addition. Okay, it's fine, it's fine. You see that there is some math theory behind the concept of data types in Haskell, and that's why they are called algebraic data types. I'll show that in a stronger, in an example, hopefully. Okay, let's just quickly, because I don't think it's necessarily going to go into it. So data, what should we do? Come on, stop playing around. I think we've all seen adjust, haven't we? Okay. So this is a sum type, and basically it's saying there's a reasoning later. If you see, I didn't really discover the reasoning and why they're a sum type. It's to do with something called cardinality, but don't worry about that. But the point being is, it can be when you use the type just of whatever the A might be, it will return you either a nothing or a just of that type. Okay, so it's this or that. Okay, so you can see that it's divided by the pipe, and then, you know, if we had like our own custom whatever, you know, it could just return poop A or whatever it might be. Okay, but you can see it can only ever return one type at a time. So it's not, you know, it can't return a nothing and a just A. It can only return a nothing or a just A or a poop A. Okay, and that's what they were going on about, or which is here. Okay, and then another one for a what would be the other one? I think a product type. So then a product type, does it explain the product type first? I'm trying to see which one they demonstrate. Does it give you any more examples? Okay, yeah, so product type is like a I mean, you'll see it in different ways. We should probably read what a product type is rather than me trying to explain it, because I might. No, go on, let's do it. So there we go. That's a product type. So because it goes poop and an int and a bool. So when we look for poop, we're after we in fact get returned that. Okay, so if we look at it, shows you there, but come on, let's read. So let's now see how the product data type looks like in Haskell. Should have maybe done the sum type first. Does it give a sum type? It doesn't look like it, does it? No. Okay. I guess sum types have been seen, you know, they're more not popular, but you can kind of make a difference. People tend to use it. It's basically when you just want like something that's over the top, and then you're going to return either just or nothing. I'm going to comment those out because they might sort of mess with my stuff. Oh, I'm going to yawn as well. Oh, goodness gracious. Okay, so let's see how product type data types look like in Haskell. Product type should have a type name. Okay, so there's a type name, data. Well, first we have the data keyword. Type name's there. Okay, one type constructor. Okay, in case we don't, we didn't explain. Let's undo that. So this is like a data type, and this is like the value just, and it expects another type, and it's just basically saying, well, you can make just whatever type you want. Why have I called it just? Oh, I'm confusing everyone. I'm really sorry. So maybe. Oh, that's so bad. No wonder I can't believe I just did that. Sorry. Yes, so we've got a maybe of A. So we see it all the time in tops of signatures, type signatures, and be like maybe of int. And all it's saying, the A is saying, well, whatever you make it a maybe of, just pop it here, and then that's what I'll return. So when you use it, I don't know. So we can go int to maybe of int, okay? And then if we do poopy x equals, so look, so it expects a maybe int. So if we do ca, so we can replace it with nothing, a just of something, whatever all these ones are, okay? But if we ignore that, so we can literally return it with a nothing or a just and a value. Okay, so we know in this example that now it needs an integer. Hold on, if I save it, now it needs an integer, and we know we've got in scope is the x, which is an integer, so we can do that. Okay, so that's valid. Look, no errors. And another valid value it can be is nothing. Totally happy. Okay, so this here is just saying, well, if you, this is a type I want, and it can either be an integer or it can be a nothing. Either of those, see? So sorry, it can be either a just integer or int, sorry, or a nothing. And in this scenario, well, we did both. We did the nothing, and what you tend to do is like you tend to do some sort of a case of whatever it is of, and then that'll either return you something, or you can whatever return a maybe or something. Yeah, because you can do this. You can do like normally it's like case blah 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 of, and then that would already be a so it'd be a nothing. So you'd be okay. Well, I'm going to return. On that case, I'm going to return nothing too. And then just a, and then just a. Okay, that's just simple. There is a function that will just do that, so you don't need to do all this writing, but it's not for now. Okay, so that's what basically what it means. You know, and these are called constructors. So there's your data. There's your type name, maybe. That's the value it expects we're putting in, and these are the names of the type constructors. So anything on the right hand side of the arrow, it then becomes a constructor. This is what constructs, or the, you know, if you think of a building construction, they're like your foundations and stuff. Okay, so on the outside we see the maybe a, but on the inside we've got the foundations of nothing and just a. So they're like the making them up. Okay, except yeah, that'd be fine. Cool. And description of, okay, so product types should have a type name, one type constructor. Okay, so in this scenario we've got two type constructors. Yeah. I keep losing it. Where am I? Oh my goodness. Okay, product should have one name, one type constructor, the function that lets you create the value of the type later. Yeah, that's fine. And the description of the fields it consists of in the view of types. And the description of the fields it consists of in the view of types. I guess it's referring to this A. I'm not sure what that means, unfortunately. So when defining custom type in Haskell, you can use the data keyword. So that's what we did. We did a data. Write the type name. Yeah, so we've just called it maybe tick. You come up with it after. Yeah, you can just, you know, name it whatever. You can rename it after. And then after the equal sign, you specify the constructor name followed by the fields. So that's for a product, but in this instance, because this is a sum, we can just literally do that. So in a product, if we look at their example, it's like the data, and then that's the type name, and then yeah, in there, this is a constructor name, that part, and then these are the types of fields. So they're the values it takes. So McKnight takes a string and an int. Okay. What's it saying? When the action custom data type could be used in the following user case. A definition of data type for a knight with a name and number of victories can look like this. Okay, so it's the name of the and the amount of victories. You'll see there's a nicer way of doing this, because I'll show you now. Stuff it. It's cheap. You could basically do like this. Whoa, 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 whoa! Can't spell it. Night is. Well, you'd probably just keep it night as well. And then you can do this. Let's put it on a new line. Yeah, and then you'd have it like what they say. So the one was the name. And that would be of type string. And then was it number of kills? Vict. victories, and of the type int. Goodness gracious, I've made a right cocks here of this. Let's put this around here. Here we go. There we go. That's better. So yeah, that's another version you can see, like that, rather than like this. Yeah. They're both still. What are they both still? Product types. Yeah, which it doesn't kind of fully go into. It's hard to sort of explain exactly what they are and why they're called product unless you start looking at type level stuff, which is like way too advanced. For now, just think of them that just happens to be their name. Because it's irrelevant, it is attached to mathematics, but it's kind of, you know, unless you start doing more complex stuff, which you don't need to, you can happily code Haskell without going too deep and having to worry too much why one's a sum type and why the other is a product. Okay, so note the constructor can have the same name as a type itself. Yeah, so here, you know, they just made it make night, but if you spot here, it's still called night in a product type. Here, I don't think that's the same scenario. Yes, it was, because we named them both just, didn't we? So if we wanted, yeah, we can have that, which wouldn't be too helpful, because then you can get a little bit confused. So, you know, when you declare it on your type signature, because when you're type signature, you use this name. Yeah, so if we look here, there we go. I'll put a tick to it. We're using that name. We can't declare a type signature with, we can't use that. If we please break. Oh, it's definitely going to break because first and foremost, let's do that. Refresh. Come on. Show us an error. There's the error. There you go. Not in scope, type constructor or class nothing. Yeah. So it's just like, well, what? I don't know what you're on about. The only thing we can use is maybe, and then that'll break also, because look, it's saying expecting one or more arguments to maybe. Well, look, we're missing this a. In this scenario, we're going to say a is an int, and then that's the wrong just, because we're using, you see, we can only return that just or that nothing. And when I was using that, oh, then look at the type message, it's saying could match expected maybe tick of int. We've returned it, where's the error? It should just say that it's going to be, yeah, look. Could match the expected maybe tick int, and we've given the actual type of maybe no tick int. So yeah, that's why it's complaining there. Okay, let's minimize that a little bit, and let's keep going. Blah, 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 blah. So the constructor can have the same name. Oh my goodness, it's getting on. I'm gonna have to stop in a minute. Let's see what. Oh, it does go on quite a bit, doesn't it? There's no real. Yeah, I might stop there on constructors, I think. Yeah, we'll stop on here. What I'll do, so I remember, I'll do some of this, because I've probably been streaming for a little bit too long. So I'm going to add some of that. Don't do it like that, just copy it. Yeah, I'll do. So I remember where we got up to, and then what I'll do is I'll carry on in the next stream. Yeah, I'm getting hungry now, and I don't know what time I started, but I think I'm getting a bit of a headache, so yeah, so I was coughing, headache. Doesn't look good for me, does it? Hold on. No, it's fine, I can still smell, so I'm alright on that side. But yeah, cool. Well, I'm going to leave it for now, and thanks for coming. I should probably try and promote my, well, it's not really promoting, it's more show. Where does it go to your channel? How can you do it? Your channel. Yeah, because why I'm going to say this is because they essentially, this is where I do all my, this is where I put all the, I've put them into playlists, all of these. streams that I've been doing so that we can catch up. Because I think Twitch just removes them. I'm not really 100% sure. I think that's what happens. Yeah. Cool. So, well, thanks for coming. Or thanks for watching, if you're watching. But yeah, try and come, because, or you know, even ask questions in the YouTube or whatever if you've got questions and stuck on bits. I don't mind helping out. Yeah, that's that. Cool. All right. Well, catch everyone soon. See you later. I've got to press buttons. I'm not gone yet, and I'm gone.